For this lesson, you'll need the required materials listed on the screen. We've been working with solving all the different types of functions, linears, absolute values, and radicals, and today we're going to work with our rational functions. We have to remember when working with rational functions, we have to determine the lowest common denominator, which is often referred to as the LCD. By knowing the lowest common denominator, that will help us undo the equation so we can solve for the variable. Again, when we are solving, you have to check your results to determine if you have any extraneous solutions. So we're going to go through a couple of examples reminding us how to solve our rational functions. We've worked with adding and subtracting, multiplying and dividing them. Now we're actually going to solve for those values that make them true statements. So here we have our equation, 4 divided by x plus 5 halves equals negative 11 divided by x. Again, we have to decide what is our lowest common denominator. So in order to determine the lowest common denominator, we always suggest making sure everything is written in factored form. So we have our denominators x, 2, and x. Those are already in factored form. And again, they have to look alike. So if I have an x here, I need an x in every single denominator. If I have a 2 here, I need a 2 in every single denominator. So my lowest common denominator would be 2x. What we're going to do now with the lowest common denominator is multiply every single term in the equation by it. So we're multiplying fractions, and when we multiply fractions, we multiply across. So in our numerators, we'll have 4 times 2x, 5 times 2x, negative 11 times 2x. Our denominators, we have x, 2, and x. As always, we're going to look at each term and see if we can simplify it. Are there any like terms that we can divide out? In the first term, we can see that they both have an x being multiplied that we can divide out. Our second term, they both have a 2 that's being multiplied we can divide out. And our third term, we can divide out our x. If you don't see that at first, you can also multiply and look again to see what can you divide out. Your x, a 2, and an x. So that would bring us here. Now I've got our equation, 8 plus 5x equals negative 22. This is a linear equation. We can continue to undo it to solve for x. So that means we would subtract 8 from each side, then divide by 5. So x equals negative 6. Like we said before, we have to check and make sure this is a solution to our rational equation. So we're going to substitute that into the original and simplify and make sure we get our true statement. So we're going to simplify our value in for x and work accordingly. So again, we want to make sure we've got our common denominator. So that would be 6, because we can do a 3 times 2 to get that. Combine our like terms. And 11/6 equals 11/6, so we've confirmed that x equals negative 6 is a solution to our problem. Let's look at another equation. Here we have 5x divided by x minus 2 equals 7 plus 10 divided by x minus 2. Again, you want to make sure the denominators are in factored form. So x minus 2, we've got a denominator of 1 here, x minus 2, they're all in factored form. Then we want to define our lowest common denominator. Well, if there's an x minus 2 in this denominator, that means every single denominator needs an x minus 2. Well, we already have one here. We're missing one here. So that would be our lowest common denominator. Multiply all of the terms in the equation by x minus 2. So again, we're multiplying fractions. So multiply your numerators, multiply your denominators, and we're here. Again, we can look to see if there are any common factors we can divide out from the numerators and denominators to simplify. We can see we have an x minus 2 that's being multiplied in each part, so we can divide that out. Nothing in common numerator and denominator to divide out here. We can divide out an x minus 2 here. After dividing out your common factors, we can see what's left for our equation. So here we have 5x equals 7 times our quantity x minus 2 plus 10. Again, linear equation. Simplify by following your order of operations. So distribute your 7. We can combine some like terms here, a negative 14 and a positive 10, that would be a negative 4. So now we have 5x equals 7x minus 4. We can combine our linear terms by subtracting 7x from each side, and that would bring us to negative 2x equals negative 4. To undo this multiplication, we can divide by negative 2 on each side. So x equals 2. Again, to verify that this is a solution to the equation, we have to substitute it back in and see if it is balanced. So we're substituting our value in for x into the original equation. We can see we've got 10 divided by 0 equals 7 plus 10 divided by 0. Well, 10 divided by 0, we're running into a problem here because we know that we're not able to take something and put it into nothing, put it into 0 groups. So since we're unable to divide by 0, it's undefined. And since we're running into that undefined situation, that's telling us that we cannot use the value of 2 for our equation. That's an extraneous solution. Therefore, we have no solution for this equation. Here's another equation. 4x plus 1 divided by x plus 1 equals 12 divided by x squared minus 1 plus 3. Again, our step is to make sure we've got things in factored form. So I look, that's already in factored form, that's in factored form, 12 is okay, x squared minus 1 is not in factored form. So we have to think about what two numbers could we multiply together to get negative 1 and add to get 0. And in that case, it would be a negative 1 and a positive 1, so we could factor our quadratic here. And so we would have x minus 1, x plus 1 for our factors, and here we have our denominator of 1. So again, we have to find our lowest common denominator. So we have an x minus 1 here. That means every term would need an x minus 1. We have x plus 1. We have an x minus 1 here. That means every term needs an x minus 1. And 1 is a part of everything, so we're okay there. So it looks like our common denominator would be x plus 1, x minus 1. Therefore, we're going to multiply every term in our equation by that common denominator. So again, multiplying our fractions, multiply those numerators, multiply the denominators, and let's see what we're working with. At this point, look to see if you have any common factors that you can divide out from the numerator and the denominator to simplify your equation. So here in my first term, I can see I have an x plus 1 I can divide out. My second term, I can divide out an x plus 1 and an x minus 1. And our third term, nothing in common to divide out. So by dividing out those like terms, we're left with our equation of our quantities 4x plus 1 times x minus 1 equals 12, plus 3 times our quantities x plus 1, x minus 1. Here, we just need to follow our order of operations. We've got some distributing to do, and probably combining some like terms. So if we do our distributing, we're here, got a little bit more distributing and combining like terms to do. And it looks like we've got a quadratic to work with, but still some like terms. We should put our quadratic terms together, our linear terms together, our constant terms together to see what type of equation are we working with. So still undo by combining your like terms. And so we've got this quadratic equation, x squared minus 3x minus 10 equals 0. Well, solving quadratic equations, we have multiple methods to do this. We could solve it by factoring, completing the square, quadratic formula. We could undo it. We want to look and see what the format's written in. This would not be a good one for undoing because we have the quadratic term and the linear term, and so that eliminates that process. Undoing is only when you have one item squared equals something. Here, we could ask ourselves maybe a factoring. What times what gives us negative 10? What plus what gives us negative 3? And we know that to get negative 10, we could probably multiply a 5 and a 2. And if we make the 5 a negative, that would also add to give us our negative 3. So we could do this by factoring. And those would be our factors. If you wanted to do the quadratic formula, that's fine too. A would be a value of 1, B would be a value of negative 3, and C is a value of negative 10. You could substitute them into the formula and solve that way. But since this lends itself nicely to factoring, once it's in factored form, we know that they're being multiplied together to equal 0. That means one of these terms should equal 0. So let's set each of those equal to 0 and solve. So either x minus 5 equals 0 or x plus 2 equals 0. To undo each of these, we could add 5 and subtract 2. And it looks like we have two potential solutions, x equals 5 or x equals negative 2. Again, to make sure, we have to check by substituting those in and making sure we're getting a balanced statement back into the original. So doing a separate check for each one, we're substituting our 5 into the original equation and our negative 2 into the regular equation and simplifying according to our order of operations to see, are they balanced equations? And we can see that we're getting a balanced equation. We're getting negative 21/6 here. This would also be negative 21/6 if you make these common denominators. And so since both solutions check out, we have two potential ones, x equals 5 or x equals negative 2. Let's take a look at one more equation. Here we have 2 divided by x squared minus x equals 1 divided by x minus 1. Again, with our rational equations, we want to make sure everything is in factored form. So as we check, 2 is okay, x squared minus x, that we need to factor. Both terms have an x, so we could write that as x times x minus 1. 1's okay, already in factored form, and so is x minus 1. So with everything written in factored form, again, we want to find the common denominator. So in order to make them look the same, here I've got x times x minus 1. That means I should have x times x minus 1 here. I have the x minus 1, I'm missing the x. Since I have my common denominator, we're going to multiply both parts of our equation by that common denominator, just like we've done before. So again, multiply your numerators, multiply your denominators. Look to see if there are any common factors in the numerator and denominator you can divide out. So our term here on the left, we can see that both of them have an x minus 1 we could divide out, as well as an x that we can divide out. Our right-hand side, we have an x minus 1 term that we can divide out. So by dividing out those common factors, we are left with our equation x equals 2. Again, we have to verify that this does work for our equation, that it's a valid solution. So we're going to do our check by substituting 2 into the original. So by doing so, substituting 2 into the original, we're going to have 2 divided by 2. Well, that's 1, and we have 1 on this side as well. So it checks out. We have one solution of x equals 2. So some of the things we have to remember, similar to when we were working with rational expressions, rational equations, make sure everything's factored form, in particular the denominators, because we have to find that common denominator. We're going to multiply each term of the equation by that common denominator and divide out any common factors in the numerator and denominator. At that point, we'll solve for the variable, whether it's a linear equation or a quadratic equation like we usually do, and check our answers to see if they are extraneous or not. Tomorrow in class, we're going to do some practice problems, again, solving these rational equations. Thanks for watching.